Good morning, e-learners. Today we are going to review Lewis dot structures, also called electron dot diagrams, and then we are going to learn how to not only draw those for single elements, but draw them when they represent a covalent bond as well. So just as a reminder, when we are dealing with, this is what we worked on class on Tuesday, and this is what your e-learning was about yesterday. When we worked on Lewis, or they're also called electron dot diagrams. Remember, we only are working, right? Oh, sorry guys, that is not focused at all. See if I can. There we go. Now what is going on? Okay, there we go. Jeez. We are only worried about those valence electrons when it comes to that. So just valence electrons. Oops. Now, those valence electrons, those are the electrons that are around the outside of the atom. So we are not worried about Bohr diagrams anymore, in which they showed us all those electrons. When it comes to Lewis, we are just worried about, we are just worried about those outside and those valence electrons. How do we find those? Periodic table. If you remember from Tuesday, when it comes to the periodic table and when we're worried about Lewis or electron dot diagrams, we are looking at the group numbers. I don't know why this is not working. Let's be a little further away. Well, I think we're just going to have to make it work because my ladybug this morning is not wanting to focus for me. So when we're dealing with the periodic table, when it comes to valence electrons for electron dot or Lewis dot diagrams, group 1 has 1 valence electron. Group 2 has 2 valence electrons. Remember, when it comes to electron dot diagrams, we skip these transition metals here. Then we have, 3 through 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we skip. Group 13, they have 3 valence electrons. Group 14, 4. Group 15, 5. Remember, when we zoomed into class on Tuesday, we all should have already done this to our periodic table to let us know how many valence electrons each group has. Group 16 has 6, 17 has 7, and then over here on our noble gases, 18 has 8 valence electrons. So now let's practice. What I would like you to do is I want you to try and draw the electron dot diagram for hydrogen. I also would like to try the electron dot diagram for fluorine, and I would like you to try it for oxygen. So go ahead and pause this video right now and go ahead and see if you can draw the Lewis structures for hydrogen, fluorine, and oxygen. Okay, so let's check our work. So hydrogen, we know, is in group 1, so we know that it has 1 valence electron. So this is so simple, we just take that valence electron and we just put 1 dot. Fluorine, however, we look for it, we see that it is in group 7, so we know that it has 7 valence electrons. Now, this is where it gets a little tricky. Remember, you want to build your house first. You want to make sure that you have an electron on all 4 sides, and then you start to pair them up. So we know that we need 7. So we go 1, 2, 3, 4. We built our house, so our fluorine is surrounded. Now we go back and we put in those pair electrons. We have 5, 6, 7. Boom, fluorine is done. That's our electron dot diagram or Lewis structure for fluorine. Let's find oxygen. Okay, same deal. Oxygen is in group 16, so we know that it has 6 valence electrons. We go ahead and we go 1, 2, 3, 4, built our house. Now we go 5 and 6. So hopefully by now this should be a review for you and you are comfortable with drawing Lewis dot structures. Let's go a little bit further and we're actually going to draw those chemical bonds. So remember, covalent bonds are bonds that form when electrons are shared. Remember, your negative electrons want to be near your positive nucleus. So what they do is they actually, when two atoms get close to one another, those electrons, if the outer shells of those valence electrons, if they match up, those electrons can actually go to both atoms and they swim around it, and that is what forms our bond. So go to your gizmo if you need a second to pause the video to open explorelearning.com. That's fine. Go ahead and do that now. But go ahead and open your covalent bonding gizmo. Now, we did this on Tuesday, but let's review. Here's our hydrogen electron dot structures. We have our nucleus, one electron. If I want to make a molecule or a diatomic molecule, two atomic atom, 2 atoms, I want to make that molecule, I just simply take these electrons and I make them share with one another. Now, what this does is this gives hydrogen is what's called a full octet. Hydrogen and helium are happy when they have 2 electrons on their outer shell. Every other element in the table, they want to have a full octet, which means they want 8. Hydrogen and helium are special just because they don't have enough electrons to have 8 electrons. So let's go through and why is this? And we see as these electrons are spinning around, they are going around both of these nuclei. Originally, they just went around one, right? We can make it a little faster. Normally they're this fast, right? They're just spinning around and around because they have that high energy. They have these 2 electrons that are going around and around. If we form a molecule, I want you to know that word molecule, that's when more than one atom are together. You form that molecule, and now that bond is formed, and those 2 hydrogens are going to stay very, 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 very close to one another because that racetrack is now around both of them. So I hope that makes sense. Let's take oxygen, for example. Now, oxygen, we know, let's show our Lewis diagram. Well, that's already showing our bond. So oxygen, we know, has 1, 2, 3, 4, 5, 6 electrons. Let's count it to make sure. 1, 2, 3, 4, 5, 6 electrons. So what you want to do is you want to make it so that this molecule of oxygen, we have 2 separate molecules right now. We want to make O2, which is what we breathe. So in order to do that, we want both atoms to be happy or stable. If they do this, they need to have how many electrons? 8. So what I want you to do is, we have 6. How many do we need in each atom to make it stable? We need 2, because 8 minus 6 is 2. So what we're going to actually do is we're going to form what's called a double bond, in which 2 electrons are actually shared. So you'll see it. Let's see. We have 2 electrons. So right now, let's hit pause. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Not quite enough are shared because we actually need to make a double bond. So what we do is we're going to take another, maybe go this way, share it, and let's see what we have. Oh man, I am having a hard time counting these electrons. So when we do it like this way, you'll see 1, 2 atoms are shared, and then, so we have 1, 2 atoms, 3, 4 atoms are shared. So what that actually does is a bond is just 2 atoms what that happens when your atoms need more than one electron? You form what's called a double bond. So right now, if you look at your Lewis dot diagram for oxygen, let's draw it together. Let's see. So we just formed 2 molecules of oxygen went together. We just saw that we needed 4 electrons shared. So I have oxygen right here, and I have oxygen right here. Starting out, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. What happened is these electrons formed a bond, and these electrons formed a bond. So our Lewis dot structure looks like this. 1, 2, 3, 4. Here's 5, 6 for that bond, but when we have that bond together, this actually represents 2 electrons. So do we have a full octet? 1, 2, 3, 4, 5, 6, and the shared 7, 8. So this molecule of oxygen, or this atom of oxygen, is happy. Let's try this one. 1, 2, 3, 4, 5, 6, 7, 8. This one is happy too. So these 2 oxygens, they're going to be traveling the world connected to each other. So if there are 2 of them, we have a special formula for it to show us what our molecule looks like. So we take our atomic symbol, and then we put a subscript for how many specific atoms are in that bond. So this Lewis dot structure is O2. This is called a subscript because it goes below the symbol. So we have 2 oxygens bound together, O2. Now, you know that water is H2O, and maybe sometimes you'll know that glucose is C6H12O6. Or salt, NaCl. There are some formulas that you already know in your head, but every molecule that exists really does have a formula because it lets us know what's inside of it. So for example, let's try a couple more Lewis dot structures. So what I would like you to do is, using your gizmo and using your electron dot diagrams, I want you to try and draw the electron dot diagrams for these formulas. I want you to try to draw N2. If it's N2, it means there's going to be 2 nitrogens. How do you think those would bond? I want you to try N2. Then I want you to try, let's try CO2, also known as carbon dioxide. So now when we get a little bit more tricky, when you're reading your formulas, you're only worried about the subscript. If that symbol is there, you're going to assume that that subscript is 1. And then after that, you take whatever subscript is there. So CO2 actually is going to look like this. We have 2 oxygen and 1 carbon. Is there any way that you can make a electron dot diagram to represent that? And then at the end, let's get a little tricky, and I want you to try ammonia, which actually is NH3. We call that ammonia, which is not that good to breathe, right? So try to draw ammonia, NH3. Try methane, which is CH4. And at the very end, we'll end with our old pal, water. And I'm not going to give you the formula for water because you should know it. Okay, so go ahead and take a moment, and I want you to draw out those electron dot diagrams for N2, CO2. I've gotten you started here: ammonia, methane, and water. So go ahead and pause the video here and try to go ahead and do that. All right, so now if you would like me, go ahead and, by now your electron dot diagrams should all be completed. Let's go through these together. So we want to start at the top. We want to start with N2. We know that nitrogen is in the fifth group on our periodic table, so we know that each of them has 5 valence electrons. 1, 2, build your house first. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So we know that nitrogen is going to need how many electrons to be happy? It needs 8 electrons. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We actually need, because we need now 3 more electrons to make us happy. So we're what is going to do a triple bond. So we simply take nitrogen here. 1, 2, 3. 1, 2, and 1, 2. For CO2, we quite simply take our carbon, which is in group 4. We know we have 4 electrons here. 1, 2, 3, and 4. For our oxygen, we know, we go back to our periodic table, we have 6. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Now, 1, 2, 3, 4, 5, 6, that needs 2 more electrons to be happy. 1, 2, 3, 4, that needs 4 more electrons to be happy. 1, 2, 3, 4, 5, 6, that needs 2. So what we can do is, to make sure that this oxygen is happy, we form a double bond to carbon here. So therefore, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons, because these electrons are going around this oxygen too, right? So this oxygen is happy. Carbon, we know, has 4. So now it's happy because we are halfway there. We have 6. Right here, we form that other double bond to this carbon. Add our 2 electrons. Comes up here. We have that full octet there. 1, 2, 3, 4, 5, 6, 7, 8. Carbon, all of these electrons are flying around carbon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is what CO2 looks, because we formed a double bond. I don't want you guys to worry about nitrogen for now. I shouldn't have used that one. That one's a little bit more confusing. So just worry about your CO2. Now, NH3 is cool because hydrogens, they only need that 2 electrons around them. So we're going to have nitrogen here. We're going to have 3 hydrogens go around it like this to form those bonds. Form your bonds first. Then count up what we have. We have 1, 2, 3, 4, 5, 6 flying around nitrogen. 7, 8 to give it that full octet. CH4, kind of the same thing. We know that carbon needs 4, already has 4 electrons, because we look here, it's in group 14. So then we go back and we put in our 4 hydrogens. And then, so between the electrons that carbon has, the electrons that hydrogen has, we now have 1, 2, 3, 4, 5, 6, 7, 8 around carbon. For each hydrogen, we have 2, because it shares them with carbon. Last but not least, we have water, which is kind of tricky. So we have our oxygen, we have it connected to our 2 hydrogens. So then oxygen here has 1, 2, 3, 4, but we know that it wants 8, so 5, 6, 7, 8. If you didn't understand any of these, how I formed these, please go back to the gizmo, and I want you to make your electron, or I want you to actually form those bonds. And then when you hit check, it will tell you if you're right or not, okay? So, and then you can actually see those electrons. A bond is 2 electrons. That's very, very, very important for you to understand. Now, once you are done watching this video, I would like you to go onto Canvas and watch the Ed puzzle. The Ed puzzle today is going to talk about water. because sometimes electrons are not shared equally. They don't look really nice like this. Sometimes you have what's called a polar covalent bond, which is when the atoms do not share them equally. And that leads to some really cool properties. So what I want you to do now is head on over to Canvas, play that ed puzzle through, and that's it for today. All right, guys, thanks so much for watching this video. If you have any questions, go ahead and email me. Have a good Thursday.